Hey, all you crazy math kids, it's time for math. Get ready to do lesson 9.8. Yes, we are skipping a couple for right now. So, lesson 9.8, you may use your calculators and a pencil and your math journal today. All right, math message. This is what you've been waiting for. We've been talking about decimals and percents and fractions, and we haven't really done anything with multiplication for a while, so today we're going to learn how to multiply when there are decimals in there, because we don't always multiply just whole numbers. We do multiply occasionally those decimals. So here's your math message. Tony has 8 blocks. Each block is 1 2/10 centimeters high. If she stacks the blocks, what will the height of the stack be? Now I know I can do this. I can take 1.2, 1.2, 1.2, lining up those decimals. I'm going to do this 8 times. This is taking forever. I don't like it. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to add those 2, 4, 6, 8, 10, 12, 14, 16. 1, 2, 3, 4, 5, 6, 7, 8. We found the answer by doing this. 1.2 plus 1.2. Yes, 9.6. All right. Or else we could go 8 times 1, and then we could add the 2 8/10 8 times. But there is another way. Of course there's another way. And if you are a lattice boxer or a traditional style, either will work. So you pick what you like to use best. In the lesson, we're going to find the product of decimals by multiplying the numbers as if they were whole numbers, and then using estimating to place the decimal point in the answer. This is probably one of the easier things because you don't actually have to multiply a lot of times in the multiplication of decimals. You just have to know a little bit about where the decimal is and what's the significance of that decimal. So first of all, we're going to estimate. Estimating means we're going to round. So in this case, I would probably round this to a 10, and my whole numbers that are on either side of this would be a 2 or a 3. So this would be closer to a 3, so I have 10 times 3, which would be 30. So I know if I actually multiplied these, my answer should be really super close to 30. Let's do the same thing for this. 110 times 2 8/10. I'm going to leave this, I'm going to take that as 100, and we're still going to keep this as 3. So that means this answer should be close to 300. Ooh, tricky one. Tricky one. Anybody know what we're going to do here? This is kind of tricky. So this time we're going to go 10 times, and I'm going to round this to 0.3. So my decimal would be 3.0. This is a little harder one. We will come to that in just a little bit. Which problem mostly would have the likely to have the answer of 30 and 8/10? This one, remember, was 30. That was pretty close to 30, so this would be our answer, 30. Okay, where would you place the decimal point? Here's kind of a cool thing about multiplying in decimals. You always know if you don't have a decimal in the place or wherever you're trying to find the answer, if you don't have a decimal in the answer, you can always look at the problem and go, okay, well I know the decimal starts here, because that would be my whole number, but now look at this one. If I moved my decimal over one spot, that would be my answer, 30.8. That's kind of the cool thing about multiplying decimals. If you know where that decimal should go, you can just move it over to however many spots. We will get to that in just kind of a second here. Okay, so here's our first problem. Calculators are on sale for $9.29 each. How much will 5 of them cost? Estimate the cost of 5 calculators. So no, we don't need to use our calculators. I know that I'm going to take this number times this number because I want to know how much 5 of them will cost. So 929 times 5. My good estimate tells me that I would round this to probably $9, and that 5 could stay the same. So I know that 5 calculators are going to cost about $45. $45, so pretty easy to do. So if you were doing this traditional style, here's how you would do it. So 929, I'm going to put the decimal point in there. It's going to go right there. I'm going to multiply like I normally would. 9 times 5 is 45. Carry the 4. Put the 5 down at the bottom. 5 times 2 is 10. Plus 4 more is 14. So I'm going to carry that 1. Put the 4 at the bottom. And 5 times 9 is 45. Plus 1 more is 46. Okay, all you do is make sure your decimal point goes straight down where it should go. So I know that I have this number, which would match this number, the ones place, the tens place, the hundreds place, the thousands place, if I didn't have any decimals in there. Since I do have that decimal, that makes this the ones place, tens place, hundreds place. So make sure that you're just lining up your numbers. So I have one number right here past the decimal, 2 numbers on this side past the decimal. So that's how you would do it if you were doing traditional style. If you were doing lattice style, this is kind of fun. You're going to make your box like you normally would, 929 times 5. Okay, put the decimal point in there, 45, 10, 45 again. Find my numbers, do my diagonals, 4, 6, 45. Here's what you do with your decimal. If you have it in that spot, you follow that decimal down to the bottom of the square or rectangle, and then follow the diagonal that it goes with. So it would go right there. So down to the bottom of the square and follow the diagonal that's nearest or closest. Right, so we've already done that. 37 times 6. We're going to estimate 37 or 6 times 3 and 7/10. So we just rounded this to, we left that at 37. I would like to round it to 40 because I can do 40 times 6 in my head. 6 times 4 is 24. Add a 0. So I know what my answer is going to be close to 240. Okay, so I have 7 times 6 is 42. 6 times 3 is 18. Put my decimal in. I should have done that at the beginning. Do my diagonals. 2. 8 plus 4 is 12. That's a 2 right there. And now look at, follow your decimal all the way down and hit the diagonal that it's closest to. Okay, so this would be 4.0 times 6, which would be 24 with a 0 after it. Move that decimal 1 spot. All right, next one. So we are on page 268 of your math journal. Please turn to 268. Devin measured the length of the room by pacing it off. The length of his pace was 2 3/10 feet. He counted 14 paces. How long is the room? So you're going to do 2.3 times 14. So I know my answer. I'm going to do a little estimate real quick. I know my answer should be really close to 2 times 14 is 28. So if I have that in my head and if I do my multiplication wrong, or if something doesn't look right, I can always go back to my estimate and go, okay, I know it should be close to 228. All right, I'm going to do 14 times 2.3. Okay, traditional first. 4 times 3 is 12. 3 times 1 is 3, plus 1 more is 4. Okay, moving to the 10 spot, I'm done with him. Moving to the 10 spot. 2 times 4 is 8. 2 times 1 is 2. All done. Add them up. Okay, my decimal goes straight down. There we go. I know that 28 and 32 and 2/10 are super close to each other. So 32 and 2/10. Spiral notebooks are on sale for 35 cents each. How much will 25 of them cost? So I'm going to do 25 times 0.35. All right. So 5 times 5 is 25. 5 times 2 is 10, plus 2 more is 12. Cross that guy off, I'm done with him. 3 times 5 is 15. 3 times 2 is 6, plus 1 more is 7. Okay, so now we got to think out where the decimal point is going to go. I forgot to do this at the beginning. So think of this, 30 cents you get. Again, you would follow your decimal down right here. You can say that these two are in the tenths and the hundredth spot. This is my whole number on this side. So I'm going to follow that decimal point right down there to $9, which is really close to what we thought. Alrighty, we are going to start on page 268 of your math journal, so please take that out. And I'm going to do these problems with you. They are a little tricky. Again, multiplication times decimals is what we are practicing today. So Devin measured the length of the room by pacing it off. The length of his pace was 2.3, and he counted 14 paces. So I know that I would probably take 2.3 or 2 3/10 times 14. Just to get an idea of what my number should be or my answer should be, I would like to round this off so that I can get close to what I'm going to be. I'm going to round this number off to 2, keep that 14. So I know my answer should be really close to 28. Something very close to that. I'm going to work down here. So I'm going to take 2.3 times 14. Let's do lattice first. I like to put the decimal number on the top. That's a little easier. Split those, split the friends. There we go. Split the friends. Okay, do your lattice like you normally would. 3 times 1 is 3. 1 times 2 is 2. 4 times 3 is 12. 4 times 2 is 8. Add up your lattice diagonals. 2, 8, 9 plus 3 is 12. And 3. So I have 322. Remember, this is how I do my decimal. So I move my decimal down the box all the way to the bottom and follow the diagonal. So my answer will be 32 and 2/10. Awesome. Okay, the spiral notebooks, number 2, are on sale for 35 cents each. How much will 25 spiral notebooks cost? Now some of you are wondering, hey, how come she didn't do the traditional style? This is where I'm going to do the traditional style. So pretend the decimal's not there, and you're going to just multiply 35 times 25. So I have 35 times 25. Just like I do over here. Okay, 5 times 5 is 25. 5 times 3 is 15, 16, 17. That's done. 5 times, oh, put my 0 right there because I'm going to the tens place. 5 times 2 is 10. 2 times 3 is 6, plus 1 more is 7. Add up my columns, 8. Okay, now this is the kind of cool thing about multiplication and decimals. All you have to remember is, when you're looking at this number, pretend that the decimal starts right here on the right of the number. So this is the decimal number, this is the decimal number. Everybody agrees. Pretend your decimal starts right here. In this particular number, 35 cents, I would move the decimal over 2 spaces. Same thing for this number. So if we started it right here, 1, 2, I know my decimal would go 1, 2 in the number. Again, pretend your decimal starts on this side. Pretend it's a whole number. Move it however many spaces you see. I see it goes 1, 2. So I go 1, 2 here. That means in my answer, I'm going to go 1, 2. So my answer, my quotient or my product is going to be 8.75 hundredths, or $8.75. Tricky. All right, number 3. Find the area of each rectangle below. Include the correct unit. Write a number model to show how you found the answer. So I have 1.5 as a height and 30 centimeters as a base. So we know it's base times height. That means we're going to take base, which is 30, times the height, which is 1.5. Now we could go 1.5 plus 1.5 plus 1.5 plus 1.5 30 times, but that's going to take us forever. So let's get our number model written here first. 30 times 1.5 equals. Okay, we will do traditional style, 30 times 15. We're just going to take that decimal point out. We know in this number we moved it over once, so that means in our quotient, our product, we're going to move it over once. 0 times 5 is 0. 5 times 3 is 15. Cross that out, move into the tens place. 1 times 0 is 0. 1 times 3 is 3. Add up my columns. Switch that down so you can see. 0, 5, 4. Okay, now we got to figure out where the decimal goes. My decimal is going to start right here. That means I moved it over one place. In my product, I'm going to move it over one place. One time over there. So my answer will be 45 centimeters squared. Okay, letter B. Again, we're doing base times height, so that would be 15.4. I moved it over to the whiteboard just so you could see. We're going to do lattice of 15.4 times 6. I'm still on number 3, letter B. So 15.4, that means I'm going to have a 3 by 1, 1, 5, 4, 6. We can put our decimal in. Let's split the friends right here, split the 4 and the 5, and draw our diagonals. Okay, 6 times 24 is, 6 times 4 is 24, 6 times 5 is 30, 6 times 1 is 6. Add up your diagonals. So this 4 is all by itself. The 2 and the 0 are all by themselves. The 3 and the 6 look like they're together. And the 0 goes there. So remember, when we multiply lattice, all we do is take my decimal, go down straight down the box, and follow the diagonal that is right there with it. So 92 point. Back to letter number 3, letter B, I'm going to do the traditional style. So I have 6 times 4 is 24. I have 6 times 5 is 30 plus 2 more, 32. 6 times 1 is 6 plus 3 more is 9. Okay, now you got to think about where the decimal is going to go. Our decimal would normally go right here in our number. And we can follow that decimal right down, straight down between the 9 or the 2 and the 4. Otherwise, we can think, this is the trick of multiplication. If your decimal started here, that means it moved one place to get to 15.4. So start your decimal here, move it one place. Same thing. I'm going to bring you back to the whiteboard. All right, for each problem below, the multiplication has done correctly, it's been done correctly, but the decimal point is missing in the answer. Write a number model to show how you estimated the answer. Then we're going to correctly place the decimal point in the answer. So this answer is correct, it's just missing the decimal point. We're going to use the cool, fancy trick. Look it. I move my decimal point 1, pretend it starts right here in that whole number spot. Move my decimal point 1, so in my answer, it starts right here, move it 1, 167.9. They also want us to do the number model to show how we estimated. So here's how I would do this. I would go, okay, so I know that 23 is super close to 20, and I know that 7.3 is closer to 7 than it is to 8. So I'm going to take 20 times 7 is 140. We can double check to look at if our answer is close to our estimate. It should be pretty darn close, which it is. That's close. Let's do the next one. Let's do the estimate first to see if we can figure out where the decimal goes and if that follows our little rule, that little trick that we have. 6 and 91 hundredths, is that closer to 6 or is it closer to 7? That is super close to 7. Times, I always use multiples of 10, anything that ends in a 0, because I can do that in my head. So I'm going to round that to 80. So 7 times 8 is 56 with 1 0. Okay, let's look. Where am I going to put my decimal? Here it is. Start right here. I moved it 1, 2. So that means my answer, start here. I'm going to move it 1, 2. My answer will be 566. Look at our estimate and our answer are really super close. All right, moving along to letter C. We're going to do the number model first. So I'm going to round this to 5,000 because that's pretty easy to multiply in my head because it all ends with zeros. Those are multiples of 10. This is probably closer to 13. If I were to give it a choice, 12 or 13, I would probably pick 13 just because it is closer to that. So now we're going to do 13 times 5, which is 65, and we're going to add 3 zeros on. So my answer should be really, really close to 65,000 if I were to put the decimal point in, which I'm going to do right now. So look at where our decimal point is. Pretend it's right here. We move it over one place. Same thing in our answer. Start right here, way over to the right, move it over one place. Now look at this number, 65,557 and 8/10. That's really close to 65,000. Excellent job. Okay, last one. We are not going to mess with this just because it's a little trickier to do the multiplication or to do the estimate. So let's just do the tricky thing that we do. If I start right here, move it over to 2 spots, 1, 2. In our answer, we're going to move it over 2 spots, 1, 2. And here's your number model for that. Pretty darn close. Awesome job. All right. Let's write a number for each estimate product, and then we're going to multiply the factors as though they were whole numbers. Okay, here we go. So our number model, would I round this to 2 or to 3? To me, that would be a 3, and I'm going to round this to 50 just because I want to do this in my head. I don't want to have to use a calculator or paper. So 3 times 50 is 150. Awesome. Number 6. Moving on to number 6, I will do both of those styles for you. First of all, let's do our number model first. I'm going to take 8, and I'm going to round that up to 6 because I know it's between 5 and 6, but it is closer to 6. So 8 times 6 is 48. I know my answer will be really close to 48. Let's set up a lattice box first and let you work on that. It's going to look like this. Put your 57 up here with the decimal in the middle. 8 right there. Split the friends. Split the boxes. Yours should be on your way. If you are traditional style, we're going to do the 57 on the top times 8. Put your decimal in. That can go trail right down there, or else we can use the trick at the end. So look at this. This is exactly set up the same way. Look at 8 times 7, 8 times 7, 56. 8 times 5 is 40 plus 5 more is 45. 8 times 5 goes right here is 40. Okay, let's go back to our diagonals. I have a 6, 5 and 0 to go together. That would be a 5 and then a 4 right there. Lattice people, decimal straight down to the bottom, follow the diagonal. Traditional people, put your decimal straight down in between those two. And you can always use that little trick that we know about decimals. If you know your answer right here, you would start your decimal right here, move it over one place. So in our answer, move it over one place. 45.6. I know that this one's going to be really close to 42 times 1. 42 probably. This is really close to $1. Think of it in money. To save time, we're just going to skip that one. All right, and cross out number 9 and number 10. Don't have to do those. Okay, and we are on Math Boxes, page 267. So if you threw a six-sided die 48 times, how many times would you expect it to land on a number greater than or equal to 4? So think about a six-sided die. How many numbers are on it that are greater than or equal to 4? Well, there's a 4, a 5, and a 6. So we have 3 times. How many sides do we have? We have 6 sides. But we're going to throw it 48 times. Okay, first you divide. 48 divided by 6 is 8. And then we multiply. 8 times 3 is 24. So you expect to land on it 24 times. Same thing for number B, letter B. I will get that set up for you and then see if you can figure it out. If you threw a six-sided die 54 times, about how many times would you expect it to land on a number greater than 4? So think of a six-sided die. How many numbers are greater than 4? Well, there's only 2. We only have 5 and 6. So that means we have 2 out of 6 chance, because we have a six-sided die, but we're going to throw it 54 times. First you divide, 54 divided by 6. Then you multiply, whatever you get, times 2. Letter B, name a percent value that is greater than 1/5. 1 out of 5 on an AR test is 20. Oopsie. And less than half, 50. So you have to give me a percent anywhere between 20 and 50. Letter B, less than 3/4. Oh, there's that fourth thing. So I know each fourth is worth 25. So if I have 3 of them, 25 plus 25 plus 25 is 75. But greater than 3/5. If you got 3 out of 5 on an AR test, you got 60%. So give me a percent. Don't forget to write the percent sign after your answers. Between 75 and 60. Number 3. This is going to be a long one, so I might do actually a separate video for this one. Just know that this is going to be Homer's, and I will explain that in a little bit. That's going to be long. Number 4, if 1 centimeter on a map represents 300 kilometers, then what is 2.5 centimeters? Either put a box around it or some type of thing. You can move one of the text boxes to the right answer. If you need to make a table for this, you may. So 1 is 300, 2 would be 600. See if you can figure out what 2.5 would be. And number 5, what is the area of the triangle? Ooh, triangle is not just base times height. Area of a triangle is base times height divided by 2. So base times height divided by 2, because we would need 2 of these triangles to make a parallelogram. Oh, I'm going to draw. That's not good. There we go. I would need 2 in order to make a parallelogram, and we know that area of a parallelogram is base times height. So in this case, we have to cut it in half. Number 6, which one is warmer? In other words, which one is closer to 0 degrees? Don't forget to put the negative signs in there. How many degrees warmer? Which one is colder? 18 minus 18 or minus 9 and 6/10. In other words, which one is farther away from 0? And how many degrees colder? So you're going to have to subtract both of those. All right, so when you finish this, make sure that you put your answers, copy your answers into the Google Classroom, and then submit it to me. Thank you.